Welcome to the Cendien Deep Dive Podcast. Today, we're jumping right into the deep end of modern AI.
That's right.
We're looking at the core stuff, large language models, the transformer architecture, and tokenizers.
The foundations, basically.
Exactly. Think of it like getting a quick guide to the brains, the engine, and the translators that make AI seem so human-like with text.
That's a good way to put it.
Okay, so let's start with the brains. Large language models, LLMs. What exactly are we talking about here? What makes them, well, large?
Well, the name really says it all. It's their immense scale. I mean, it's kind of staggering.
How staggering?
We're talking tens, sometimes hundreds of billions of parameters. And they're trained on just, terabytes of text data.
Terabytes, wow.
Yeah, and it's not just about size for size's sake. This scale is what leads to these really interesting emergent abilities.
Emergent abilities, like unexpected skills.
Exactly. Things like reasoning or maybe some basic planning that the model wasn't explicitly trained to do. GPT-3 was a big example of this. They sort of become these versatile foundation models.
Right. Pre-trained on everything, ready for anything.
Pretty much. Adaptable for loads of different tasks.
Okay, so these emergent abilities, that sounds like a huge leap. But does this massive scale have downsides? Big trade-offs?
Oh, absolutely. It definitely reshapes how we see AI learning, but the trade-offs are significant. Training these models takes, well, enormous computational power.
Right, you hear about that?
And running them, inference, is also slow and expensive. It uses a ton of resources.
So it's costly.
Very. And that raises an important question. It means that access to the really cutting-edge stuff tends to be centralized with the big companies that can afford it.
Yeah, a kind of digital divide for advanced AI. Makes sense.
It's a real challenge for, broader innovation.
Okay, so we have these giant brains, the LLMs. But how do they actually process language so effectively? It needs an engine, right?
Well, exactly. And that's where the transformer architecture comes in. It's been pivotal since, 2017?
Read the paper, attention is all you need.
That's the one. It really changed the game for text processing. Its big advantage was enabling way more parallel processing compared to older models that had to go step by step.
So faster.
Faster, yes, but also better at understanding context over long distances in the text. That's thanks to its core idea, the attention mechanism, especially self-attention.
Okay, attention. Can you break that down a bit? You had an analogy.
Yeah, think about being in a noisy room, maybe a party. You focus on your friend's voice, tuning out the background chatter.
Right.
Attention, especially self-attention, lets the model do something similar with words. It dynamically weighs how important different words in a sentence are to each other, no matter how far apart they are.
Ah, okay. So it gets the long-range connections, speed, and deeper context. Are there limits, though? Any practical constraints?
Yeah, the standard transformer design has this issue with quadratic complexity, meaning the compute cost explodes as the text input gets longer. So processing really long documents becomes super expensive or just too slow. It has a kind of fixed length limit it handles efficiently.
Okay, so not perfect for, reading a whole book at once easily.
Not the standard ones, no. But there's constant innovation. Things like Transformer XL, for example, have clever ways to handle much longer sequences more efficiently, reusing information. The push is always towards more efficiency.
Makes sense. More power, more accessible. All right, so we've got the LLM brain and the transformer engine. But how does the engine even get the fuel? How does it read our words in the first place?
Good question. That's the crucial first step, and it's handled by the tokenizer. It's like the translator.
The translator. Okay.
Yeah, it's usually a separate piece. It takes the raw text you type in, cleans it up a bit, and then splits it into smaller pieces called tokens.
Tokens, like words, or...
Sometimes words, but more often they're subword units. Think parts of words. Then it converts these tokens into numerical IDs, and those IDs get turned into something called embeddings.
Embeddings? Yeah. Those capture the meaning. Right, in a mathematical way.
Exactly. They represent the semantic meaning of the tokens as vectors, which the transformer can then process.
So subwords seem common. Why that method? How critical is picking the right way to tokenize?
Subword tokenization, like BPE or word piece, is dominant because it's a really good balance. It keeps the vocabulary size manageable, but can still handle pretty much any word, even new or rare ones, by breaking them down.
Okay, handles unknown words. It's useful.
Very. But choosing or designing the tokenizer is super important. There are challenges like spurious ambiguity.
Spurious ambiguity.
Yeah, it means the same sequence of text could potentially be tokenized in slightly different ways, which might confuse the LLM down the line. A poorly chosen or trained tokenizer can seriously hamstring even a brilliant LLM.
So the translator has to be really good, otherwise the engine and brain don't get the right message.
Precisely. It's a foundational piece, often overlooked, but absolutely critical.
Wow. Okay, what an incredible journey through the brain, the engine, and the translators of modern AI. Tokenizers bridge our language, transformers process it with attention, and LLMs scale it all up for these amazing capabilities, even those emergent ones.
It's a fascinating stack. And complex. They come with those significant costs we talked about.
Right, high maintenance.
Indeed. And the future is really about pushing on two fronts, continuing to scale up to see what new intelligence emerges, but also, crucially, working relentlessly on efficiency, making them faster, cheaper, use less energy. That's key for wider access and, sustainability.
Absolutely. So a final thought for you listening. Understanding this interplay, LLMs, transformers, tokenizers, how does that change how you see AI intelligence? Remember, it's not quite human understanding.
Not yet, anyway.
It's incredibly sophisticated pattern recognition based on statistics and math. Thinking about it that way, does that shift your perspective on AI's potential and its limits? Something to chew on. Thanks for diving deep with us today.